The Zeroth Law of Thermodynamics. This is the first of 4 laws that we'll discuss. Zeroth Law, first law, second law, and third law of thermodynamics. When 2 objects are thermally isolated from their surroundings, so thermally isolated means that we have adiabatic walls, like we talked about, no heat in or out. They eventually reach, when 2 objects, this is actually a repeat of the idea of thermal equilibrium. Remember, if 2 objects are isolated from their surroundings but are in thermal contact with each other, then the heat will flow from the hot to the cold object, and they'll eventually reach the same temperature. So afterwards, there's no heat flow between them, and that's what we called thermal equilibrium in Chapter 12. So this Zeroth Law of Thermodynamics is closely related to that. In fact, it's almost identical. 2 systems individually in thermal equilibrium with a third system are in thermal equilibrium with each other. So the idea here is this. If this box is system 1 and this box is system 2 and this thermometer is system 3, then what this Zeroth law says is that if 1 is in thermal equilibrium with 3 and if 2 is in equilibrium with the same thermometer, I'm going to take that thermometer, move it over to here, and if they're in thermal equilibrium with each other, meaning that the thermometer reads the same thing in both places, then those 2 are in thermal equilibrium with each other. So then that means, so if 1 is in thermal equilibrium with 3, 2 is in thermal equilibrium with 3, then 1 must be in thermal equilibrium with 2. And so what this says is it's a subtle meaning, because what it says is that temperature is the indicator of thermal equilibrium in the sense that there's no net flow of heat between 2 systems that are in thermal contact and that have the same temperature. So it's essentially the concept of thermal equilibrium that we talked about before, but with an added bit that temperature is really it's what you use to define thermal equilibrium. If 2 systems have the same temperature, then they are in equilibrium with each other.